Okay.
So let's see, where is it? Part 2. What is the explanatory variable? I said head length.
Okay. What's the response? I have body length.
I have a scatter plot that looks like a scatter plot.
Good, good. Me too.
Use the software to compute the value of the y-intercept in the regression line. The y-intercept is negative 69.369.
Okay, and then find the slope at 7.4.
What is the equation for the regression line computed by the software? Y hat equals negative 69.369 plus 7.4x.
Okay. And then I have another scatter plot with a line through it. Okay, so number 8, the observed body length is 343 centimeters.
Use the regression line obtained in number 2 to predict the body length based on the head lengths. So 308.031 centimeters.
Okay. And then why are the values different? They're different because not all the points in the line are exactly the best fit.
Okay, awesome.
Okay. True and true. So given the linear equation y equals 2.0 plus 1.5x, what's the y-intercept?
So it would be...
would it be 3.5x then?
What the y-intercept would be 1.5.
Well,
The formula is y equals mx plus b, where m is the slope and b is the y-intercept.
okay. And then what's the slope? So that'd be 2.0. All right, now's the actual equation. So negative 3. Do you multiply like the y-intercept with the x first, or is it just kind of left to right thing?
You multiply them together first.
Okay, that's what I thought. Just wasn't sure. Times. All right, I have 1.
What did I do wrong? Hold on, let me get my other calculator. One of my phone is being stupid. Yeah, I got 1.
Okay, cool.
So 1.0.
Mm-hmm.
Oh, we are going to have to use...
That's okay, I got it to work finally.
Okay. So many tabs.
I know.
Hi!
Hi, Fallon. Cannot hear you. No. I had to leave and come back because I had the same issue. So you can try that. No. Just saying. Alright, math self-decisions.
Oh, oops. Sorry, Fallon. I didn't answer your question. I was trying to get SPSS to work. Hi.
Can you guys hear me?
Yeah.
Yes.
Yay!
Hello.
I
Yeah,
had the same issue. I don't know.
how weird.
See, this makes me feel better about myself because I always have this problem.
You're the one with the problems, always. That's true. Where are you guys at?
We are on number 6.
Number 6.
What are you putting as the y and x axes?
I am
the
not
measurement
there
and the
yet.
score? Okay. I think it's that.
Graphs.
I'm
Is
going to say
this-
it's a hot dog shape, but I don't really know.
Is this already the
The quiz.
Quiz.
Yeah.
quiz? Oh, okay. Oh, okay. Gotcha. Let me get on it.
Okay, let's see. I don't think it really matters. The score would be one and the
Oh, yeah, I
confidence rating
just
would be
made-
the other.
I just made the charts.
It didn't like me.
Oh,
I
oh,
obviously
I know
didn't
you're
do
saying
something right.
Yeah, you have to do the score without the little A on it, if that makes sense.
Oh, there it is. That looks like a spaceship. Is that an option?
No.
No.
Yeah, hot dog,
Spaceship.
hamburger, or banana. I said hot dog.
Let's go with hot dog. Looks like a
Where-
hot dog.
Were you able to open VMware?
Yeah, I finally got it to work.
Okay. Because mine's not opening. I don't know if... I had to run... if I were to make it home, I would be home by 7. So I stopped at the church. So I don't know if that's what it is. It's not letting me access it.
I'm surprised your church is open right now.
There's a Relief Society activity, so
Okay.
yeah. Yes, not opening. So the scatter plot should have a shape that looks either like a hamburger or a hot dog.
Apparently.
And we're going with hot dog.
Okay. So based on the shape, is this being already broadcast?
Yes.
Okay. Based on the shape of a scatter plot you produce in question 6, what can you say about the appropriateness of using simple linear regression to model this data?
I don't even know what that means.
I don't think it's appropriate
For this data?
because it's all over the place. It's not, you couldn't draw a line through it.
So then do you really want to say that it's a hot dog? Because a hot dog will lead more into a linear thing.
I
Same,
think that it
same
would
with
be
the
appropriate
banana.
then because the banana would, I think, would have more of a curve. I read this somewhere, but I don't
Can you
remember what it
see what I just pulled up?
was. Hang on. Yeah.
Can you share this? You're sharing the screen right now?
Yeah, that's what it looks like.
Oh, I can totally see the spaceship now.
Me too. Me too.
Okay. Oh, hang on. Let me share my screen and I'll show you their examples. I just looked up the. Okay. This is the examples they have of the hot dog, hamburger, and banana.
It's completely pitch dark.
You don't see it?
Do you see it, Margaret?
When it's talk, Rebecca, say something.
Okay. I don't know.
Oh, there.
Yes. Keep talking.
Keep talking.
I don't know what to say. But alright, so the hot dog is a linear. Hamburger's random, apparent random, and then non-linear is the banana. Okay, am I good? Do you see it?
Can you still share yours again, Margaret, just to see it really quick?
Yeah, hold on. Do that, and then come over here. Oops. No, don't do that. Bad computer.
Oh, no. And based on yours.
Sorry, I clicked off of it. Alright, there you go.
It's still dark again.
Oh my goodness.
There.
Do you see it?
Yeah.
Okay.
I guess, yeah, the best shot is definitely the hot dog.
Mm-hmm.
So it says the hot dog is linear then.
So, yeah, it's linear, and it says conduct regression analysis to determine if there's a significance linear.
Okay.
So simple linear regression is appropriate for these data then.
Okay. How many observations are in the mass self-efficiency data? I don't know. I don't know, 139? Like, I don't know what it's looking for.
I would say
Yeah,
it's
139. It says a group of 139 students. Yeah.
139 students?
I'm not sure why it's asking us that.
Okay. Questions 10 through 13. Use the math self-efficiency data to answer these questions. Be sure to use the confidence data for the explanatory variable and the score data for the response variable. What is the y-intercept?
Okay.
This is assuming I remember how to do that. Let's see.
I didn't get to the videos of this, so I'm not quite sure if I know how.
What is the question again? Let's see. What is the y-intercept?
Alright, scroll down the bottom of this data.
Would it be to use SPSS to predict the value of y
I think
for any specified value of x?
I think so. After the last row of data, type the value of x. I don't understand. Scroll down to the bottom of your list of data in SPSS. So like underscore?
Hold on. Let's look at the formula. Okay, it's something else, because the b with the 0 is the y-intercept and the b with the 1 is the slope.
Mm-hmm.
So, choose the menu option Analyze,
Okay.
Regression,
Okay.
Linear,
Okay.
move the dependent variable to the dependent box.
Okay, which one are we saying is
The
dependent?
dependent variable is also known as the response variable.
So the confidence rating, I would assume, because it's the measure.
Let me look, because it told us in the response variable is score.
Okay.
And
So
then
that's
confidence rating will be the independent.
okay.
Move the independent variable into the independence box. Click OK.
Okay.
Okay.
And what is that? It says that the regression coefficients are given in the table under the heading on standardized coefficients?
Under standardized coefficients. So, wait, this does not look like what the book has. Oh, there it is. That one looks like the book. So, the y-intercept would be the 18.690, and the slope would be 12.695.
Okay.
18.1?
Hold on, let me... 18.690.
And then the slope?
Is 12.695.
12.695.
Yeah.
And for number 11, I got 87.455.
Hang on.
Assuming I put the things in the right order.
69.47? Is that what you got?
Oh, I did it backwards.
Okay.
You're still not opening.
Well, what you do with 11 is you just multiply you do number 11 plus number 10 times 4, which they give you a number.
But
I take it back
11.
number 9. I take it back number 9 plus number 10 times number 4, which is in the question for 11.
I got 69.47.
All right, me too.
69.47.
Okay, I don't know how to do this next part either.
Okay. We can use the largest x value to find the largest predicted y value. So I think that's what we were looking at before, where we were supposed to go to the bottom of it.
Mm-hmm.
And so wouldn't the greatest be 6?
I don't know. What do you mean?
So it's on a scale of 1 to 6.
Oh, okay.
So if we want to say what the x is, then wouldn't the maximum, it could be 6? So you put 6 down at the bottom?
I guess.
And then after, you predict the value of y in the cell after the last row in the x column. For example,
in the confidence rating mean 1, 6?
Yes,
Okay.
I think so. So after the last row of data, type the value of x for which you want to predict the value of y in the cell after the last row in the x column.
And the hint says because there's a positive correlation, we can use the largest x value to find the largest predicted value of y.
Okay, so for example, if you want to predict the body length of a crocodile with a head length of 87 centimeters, then you would type 87 at the bottom of the head length column. Do not type anything in the column corresponding to the dependent variable, otherwise SPSS will assume that you have measured one more data point, and this bogus value would be included in the regression calculation. So choose the menu option, Analyze Regression Linear, move the independent predictor, so the head length, so it would be the 6 confidence rating, into the independence box. move the dependent variable body length into the dependent box. So that would be score. You want to save the predicted values, so do the following. Click on Save, mark the checkbox for under standardized predicted values, click Continue, and then click OK.
Alright, where's this save? And what box are we clicking? Under unstandardized?
Unstandardized predicted values.
And then OK.
This is the predicted value of y, right?
Yes.
Okay.
Okay.
Called the
SPSS will create a new column in the data set called PRE1. This column will contain the predicted value for each value of x that has specified in the data set, including the one you added at the bottom.
Okay, so I see that.
It says 94.85900.
And it can be that large of a number?
Yeah, because it's a score on a test.
So it's 94.8500?
900.
Are you just doing the 3 decimal places?
It says your answer should be exact, so I'm using all of them.
Okay.
So you said
94.85900.
Oh, so we cannot round at all. Gotcha.
Okay, how many explanatory independent variables are present in a simple linear regression?
Let's see. What is that?
It's not in my apartment.
It might be my TV in the background. My dad has the Charlie Brown Christmas on.
Oh,
I don't know if you can hear it.
I can hear the, what is that? And then there's a,
Snoopy.
oh. Let's see.
I can't find anything that says.
Yeah, me neither. I'm looking at the lesson.
When in doubt. I think it's a single independent one. So 1, but I'm not sure. I would think because it's simple. I don't know
Is the independent, I always get these confused. Which one is dependent on the other?
Dependent. Wait, what? What do you mean?
Which one
Like,
is the
one of them doesn't change regardless of what the other one is.
I think that's the independent, if that's what you mean.
Because if it's not going to change, it doesn't matter how many of the other there are. But if it is going to change, there should only be one.
So how many explanatory independent? So independent, it shouldn't change, so then therefore would be 1. But dependent variables. Would it be 2 or more than 2?
I think so.
How many variables do we have? Can you see it on that confidence data? I don't have access to it, so I can't see it. But when you go to where it says variables in the bottom, does it tell you?
They're both 1.
So both 13 and 14 are 1?
Yeah.
Okay. All right, so ready to. Oh, Fallon, do you need the
3.
first?
Yeah. What's 3?
1.5.
Nope. I submitted it. It's not. It's 2.0.
What's
Oh,
2?
were they backwards?
We were backwards. So 3 is 2.0 and 4 is 1.5
1.5?
and 5 is 1.0.
Okay,
Oh, it's still
3, 2.0, 4 is 1.5, 5 is 1.0.
Yes.
And then we said hot dog shape, simple linear regression is appropriate for this data, 139, 18.690, 12.695, 11, 69.47,
Yes.
Yep.
and 1294.85900.
Yes. Okay, so I'm going to